welcome to our revision program for the final exams, which is in like exactly probably around 2 weeks time. Okay, from what I hear, around the 21st. So we're dealing with some exam questions on integration by parts. So I've taken some questions from the November 2023, and as you can see, August 2023, March 2023. The 2024 papers, the integration by parts was similar to the easier ones that we've done yesterday. Okay, so these ones here were a bit tricky, especially this one. Okay. So now, with integration by parts, remember we are dealing with a multiplication problem. We are dealing with a multiplication problem. Okay. So you might wonder, where is the multiplication here? Where is the multiplication here now? Because if you're multiplying two factors there. Okay, but you only see one here. These two examples are similar. It's just that this is ln, which has a base of e, and this log, well, this one has a base 2. Okay, if there was no base for logs, it would be 10. Okay, so integration by parts, you have an f of x times g prime x dx. Okay, we know that is the formula. F of x times g prime x. So it's multiplication of f of x times g prime x. So the trick here is to multiply by the number 1, because anything times 1 is equal to itself. Right, so now we have created that multiplication problem. Now, can you see that? We've created the multiplication problem. So this 1 here now, the 1 can actually be written as x to the power 0. X to the power 0 is 1. Now it is clear to anyone who's doing this problem, from your priority list, log is number 2. Powers of x, number 3. So whichever one is higher up on the priority list, logs are higher up on that priority list compared to powers of x. So whichever one comes first must be chosen as f of x. Okay, so let me do the working out on the side. So I'm going to let f of x equal to log x to the base 2. This is from the priority list. Okay, so now therefore once I do have my f of x, the other one automatically is g prime x. So I'm going to go, therefore g prime x is equal to x to the power 0. Now I can work out everything else. Alright, so f prime x now. We need to differentiate log. The problem is, on the N5 formula sheets, they don't give you the first derivative for log. They give you for ln. So you can convert this problem from log to ln. It will be a bit complicated, or you remember it from N4, like what I taught you. So what did I teach you in N4 is that if y is equal to log f of x to the base a, this is the formula for log, that's not given. Best to memorize this one. Okay. So dy over dx, the first derivative of log is going to be f prime x all divided by f of x times ln a. It was in the N4. Okay. It's not directly in N5. Memorize it so it'll be easier instead of converting this to ln. So that's the formula. So in this case, my f of x here is x, the base a is 2. Can you see that? So the formula is going to be f prime x, which is 1, all over f of x, which is x times ln of the base. So that's going to be ln 2. So we've got that sorted out. We've got our f prime x. Okay, now we need g of x. So this is g prime x. So if I want g of x, I need to integrate x to the power 0. Basically, I'm integrating 1, which is x to the power 0. Okay, so now when I integrate x to the power 0, what do we do? 0 plus 1 is 1 all over 1, which is just equal to x. You're clear with that? So we have our working out here. This is the working out before the actual formula. Okay, so we have all this information. Now there's the question, and this is equal to. Now let's write down the integration by parts formula. Okay, so the formula, that formula is on the formula sheets. So the formula is f of x times g of x minus, you've got your integration sign, and that's going to be g of x times f prime x dx. Okay, so we write down the formula, and now you have all the information. We're going to substitute it. So my f of x here is log x to the base 2. Okay, my g of x is just x minus the integral of g of x, which is x. There's my g of x, which is x. And then f prime x, we just found f prime x now. Can you all see that? We found f prime x, which is 1 all over x, then 2, and that's my dx. Okay, now what do we do after substituting? We simplify, take our constant, write it before in front of the integration sign. So let's do that. This, there's nothing more to do. We're just going to copy this down. Okay, so that's going to be x times log x to the base 2, or you can leave it as it is. It's just multiplication. Now I've got a minus here. I've got my integration sign. Okay, so the constant is a fraction, which is 1 divided by ln 2. Ln 2 is a number. Okay, so 1 divided by ln 2 there. Now I just have basically x over x. X over x is just 1. And now all we have to do is integrate 1. So that's going to be x log x to the base 2 minus 1 over ln 2 times integrating 1 is the same thing there, which is just x. You're clear with that? Plus c. It wasn't bad, not a bad problem, unless if you didn't know the formula for log, it's going to be a problem for you. Right, so that's going to be x log x to the base 2 minus, if you want to leave it like this, or you can write it as 1 times x, which is x all over ln 2. It's unnecessary to do this here, but that is it. And that is the first one from November 2023. Let's get ready for the next one in a few seconds. Alright, so the next example here is from August 2023. Looks a bit complicated. Now when a maths problem is complicated, then they give you a hint. Okay. Why does it appear complicated? Because this is a 3x and this is a 6x now. There's going to be a problem. Okay. So let's see how we're going to overcome this problem. Normally, the coefficients must be the same. Okay, but it's not the same now. So what to do? Use the hint. They didn't give you a hint for nothing. Okay, let's use the hint. So if I let u equal to e to the power 3x, what do? We find du over dx. Now, if you forgot, how do you differentiate e? Go back to your N4. Remember this formula? When you differentiate y is equal to k times e to the power f of x, y prime is k e to the power f of x times f prime x. So I'm going to apply that formula to find the derivative of e to the power 3x. So the derivative of e to the power 3x is e to the power 3x times f prime x, which will be 3. We're clear with that? So now we're going to make dx the subject of the formula, which is going to be du divided by 3 e to the power 3x. You can see that? Alright, so let's substitute. Let's see what happens when we substitute. So now I've got the integral there. I've got e to the power 6x. So this is e to the power 6x times sine of e to the power 3x. But e to the power 3x has been replaced with the letter u. So there's your u here. And then dx is du. Dx is being replaced with du over 3 e to the power 3x. So that's going to be du divided by 3 e to the power 3x. Okay, now what do you notice? What can happen here now? Remember, you have a constant. Okay, let's deal with the constant first. The constant is your 1 over 3. You write it there. You're clear with that? Now, you notice that you have e to the power 6x on the top divided by e to the power 3x on the bottom. Can you see that? So this is exponent laws. When we are dividing and the bases are the same, you write down the base once and you go top minus bottom. We're clear with that? So this is going to become e to the power 3x times sine u du. Right, you're clear then? However, now, whenever we transform a problem from the variable x to the variable u or any other variable, like in this case, we are integrating with respect to u. That means anything with respect to x must be transformed in terms of u. We cannot have e to the power 3x. Can we replace this? Yes, because e to the power 3x is actually u. So now, this is equal to 1 over 3, and that's u times sine u du. Now only will you be applying integration by parts, because it's a multiplication problem here. Can you say that? It's like if you're confused with u, think of it as x sine x dx. You know what I mean? If you're confused with the letter u, it's just a simple multiplication, integration by parts problem. So what will I do now by working out for integration by parts? So f of u, I'm not going to call it f of x now. Alright, well, I'm going to the priority list now. The priority list for choosing f of x normally is just that it's now f of u. So between u and sine u is like x number 3 on the priority list. Sine u is like sine x number 5 on the priority list. Which comes first? X comes first. In this case, it is u. Okay, so f of u will equal to u. So therefore, g prime u, the other one, will be sine of u. So priority list first, make the correct choice, and now we can work out f prime u. It's like differentiating x. You are clear with that? F prime u will be 1 g of u. That means I need to integrate sine u with respect to u. When I integrate sine u, I'm going to get minus cos u. Plus c, we don't have to put down plus c, that's not our final answer. Now we have our working out for integration by parts. Here's the chart. This was the working out just to get to the stage here. So from here, we now go to the next step. That's your 1 over 3. Okay. my 1 over 3 there. But now I have to open up a bracket here. Okay, I have to open up a bracket because I need to apply the formula now. So the formula is normally f of x, but we now write it as f of u times g of x, so it's going to be g of u minus the integral of g of u times f prime u d. Just that it's transformed to u now. Okay. Close the bracket there. Let's substitute. So that's 1 over 3. What is my f of u? It's u. What's my g of u? G of u is minus cos u. G of u again minus cos u. And then f prime u, which is just 1 du. Okay. So let's close there. So now I've got my 1 over 3 there. I've got a positive times a negative there, which is a negative u cos u, a negative times a negative there, which will be positive, the integral of cos u du. Are you clear there? So now only one more thing to do is just integrate cos, and I'm done. Integrating cos, what do you get? Positive sine u plus c. You're almost done. Don't forget that there was a u substitution, so you must substitute back in your final answer. That's minus u, which is e to the power 3x, cos of u, which is e to the power 3x, plus sine of u, which is e to the power 3x, plus c. You're done. It's unnecessary to multiply this 1 over 3. Unnecessary. So you can leave it as it is. And that is the second example. Alright, so this one from the March 2023, you can see most of the questions are always 4.1.5 in the paper. Can you see that? Integration by parts, most of the time 4.1.5. Now this one was it was a challenging example, this one, compared to most of the examples. Because it's not straightforward. Look at, they gave you a hint here. Whenever they give you a hint, you must know the example is not straightforward. Use the hint. So now, the hint is, let f of x equal to x squared e to the power x squared. And then you wonder, where is x squared here? Because that's x to the power 3. Right? So, your job is to try and rearrange this. So you have this part, x squared e to the power x squared, as a multiple of something. So what do I mean? Okay, so you write it like this. This is x squared times e to the power x squared. Alright. So if this is the case, and if this is part of that, then this is not an x squared, this is x to the power 3. So that means x squared times x will give you x to the power 3. All divided by x squared plus 1, all squared, and there's my dx. Now, we have the hint. Can you see the hint now? It's there now. Okay, so what to do? If this is unusual, not exactly like the priority list. Why? Because this involves both number 3 and number 4 here. Can you see that? It's a bit of a complicated example that doesn't follow the natural rules that we normally use now. See? So, let's do it and let's see what happens. So if f of x is equal to this, and this is a multiplication problem, then f prime x, in order for me to differentiate this, I need to use the product rule because it's multiplication. So the product rule is copy the first, differentiate the second. The derivative of e to the power x squared is e to the power x squared times 2x. And I just had it on the board. Here, the derivative. So let's write down the first, differentiate the second, plus write down the second, which is e to the power x squared, and then differentiate the first, which is 2x. And I notice there's a common factor that I can take out. Okay. So my common factor here will be 2x times e to the power x squared. Okay. So if I took out 2x times e to the power x squared, I'm left with x squared plus 1. Okay, so that's as far as I can go with this f prime x. How are we going to use it? We don't know at the moment. We have no idea. We need to now write down what is g prime x. Remember this integration by parts. If this is f of x, that means the other part has to be g prime x. So g prime x is this part here, which is x all divided by x squared plus 1 all squared. You're clear with that? So g prime x means that this is an answer to a differentiation problem. So I need to get g of x. That means I need to integrate this. Now, in order to integrate something like this, there's an x squared here and there's an x to the power 1 here. Can you see that? That means this falls under the topics on exact derivatives. Use substitution or integration by inspection. So that means you take this to the top. This becomes minus 2, and that's x dx. How do we integrate this? Okay, let me just do it the long way quickly, but there is a shortcut is integration by inspection. The other way is let u equal to x squared plus 1. So now du over dx, the derivative of x squared plus 1, 2x. Make dx the subject, du over 2x. So therefore, this is going to equal to u to the power minus 2. There's x and there's du over 2x. Can you see that? So x and x cancel, we end up with 1 over 2 u to the power minus 2 du. You follow what's happening there? So now this can be written as, we can integrate it, minus 2 plus 1, that will be minus 1 plus c, I'm not writing down plus c, which is actually equal to minus 1 over 2 u. If I take this u to the power minus 1 to the bottom, sign of the exponent changes there, which is actually equal to minus 1 over 2 times u. What was u? X squared plus 1, exactly. I told you this is not a simple example, it takes quite long. So, we've got our f of x, we've got f prime x, we've got g prime x, and now we've found g of x. Now, the formula. Okay, so there's a question, the formula is f of x times g of x minus the integral of g of x times f prime x dx. That is the formula to integrate. Okay. Now, let's do the substitution. Right, you need to be careful. There's a lot of work that has been already done here. Can you see that? So, what is my f of x? Which is x squared e to the power x squared times g of x. There's the g of x here. Can you see the g of x? Which is equal to minus 1 over 2 times x squared plus 1. There's my g of x there. You can see that? Minus the integral of minus 1 all over 2 times x squared plus 1. That's my g of x. And the f prime x, where is the f prime x? There's a chair now. Can you see the f prime x? There's a chair. So what is f prime x? F prime x is 2x times e to the power x squared times x squared plus 1 dx. So now remember, I said that we do not know how we're going to be using this. When we took out a common factor, we just factorized it and we didn't know what was going to happen. Now we can see why we had to do this, because the x squared plus 1 and the x squared plus 1 cancels now. Can you see that? So what remains? Let me just copy this down. So that's now minus x squared e to the power x squared. That's 2 times x squared plus 1. I'm just rearranging this. Here, what can happen here? 2 and 2 cancel. Negative times negative is positive. That and that cancel. So that's a plus x e to the power x squared dx. Am I correct there? Any mistake there? No, everything else cancels it. Now, what are we dealing with? Use substitution example. Because we have an exact derivative. This is x squared, this is x to the power 1. So you know it's an exact derivative example. So you can do it by use substitution or inspection. If you let u equal to x squared du over dx, what's the derivative of x squared? 2x. So dx is equal to du over 2x. Alright, so you see, if using use substitution takes quite long. This thing can be done shorter by inspection, but this is a little bit more understandable. Can you see that? So I've got my x e to the power u, and that's du over 2x. Can you see that? So x and x cancel. I end up with just e to the power u du. And when you integrate e to the power u, it's just going to be e to the power u. So that's going to be plus e to the power u plus c. This, you're going to copy it down all the way. So let me just write down my final answer. Okay, so the final answer is this, plus e to the power u. So that's going to be minus x squared e to the power x squared all over 2 times x squared plus 1. You can see that. And that's going to be plus e to the power u. What was u here? That was x squared plus c. And that was one of the most complicated ones we dealt with. Right.